to express a repeating decimal as a quotient of two integers, we're going to first make an equation out of that repeating decimal by letting x equal to the decimal in that repeating bar form. Now I'll create an equivalent equation without the repeating bar. So without the repeating bar, the digits directly under the bar are going to repeat exactly the same way over and over again. My next step is to multiply this new equation by a power of 10. 10, 100, 1,000, whatever it takes to move the decimal point behind one complete repeating block. Well, a complete repeating block is just a 7, so I need to move it one place. To move a decimal point one place, I'll multiply by 10. So what I have is 7 point, and then all these repeating 7s. Put it back in repeating bar form. It's the digits that are behind the decimal point that repeat in exactly that form. Let's get a bar. Now let's look at the two equations. This new equation and the original equation. The goal is so that only the repeating block be behind the decimal point. If we've achieved that, we can subtract the two equations. And the repeating block will drop out. Anytime you subtract anything from itself, you get 0. Then 7 minus 0 is 7. 10x minus 1x is 9x. And I'll solve for x. Divide both sides by the 9. So x is 7 over 9. Now if I wanted to write one, 3, 5 with a bar over it as the quotient of two integers, I'll start out by letting x equal to the decimal number in repeating bar form. Now create an equivalent equation without the repeating bar. Well, the bar is over the digits 1, 3, 5, so it's the whole 1, 3, 5 that keeps repeating over and over again. So our next step is to multiply both sides of this new equation by 10, 100, 1,000, whatever it takes to move the decimal point behind one complete repeating block. Well, one complete repeating block would be the whole 1, 3, 5. That's what keeps repeating over and over again. So to move a decimal point 3 places, we'll multiply it by 1,000. So what I have is 1, 3, 5 decimal point, and there'll be these repeating 1, 3, 5s. Put it back in repeating bar form. So it's what's behind the decimal point that keeps repeating that gets the bar. Now we'll look at the two equations, the original equation and the new equation, and see if we've isolated that repeating block. We have. So in that case, we subtract the two equations. So I have 999x equals, the repeating blocks would drop out. So 135. Okay, I'll make a fraction out of it. Divide both sides by 999. And reduce. This reduces to 5 over 37. But this next one's a little bit different. The repeating decimal that we're given is 2.15, but the bar's only over the 5. So I'll start out, I'll let x equal to the decimal in repeating bar form. Now I'm going to create an equivalent equation without that repeating bar. So it's 2.1, and it's the 5s that keep repeating. So our next step is to multiply both sides of this new equation by a power of 10 to move the decimal point so it's behind that first repeating block. So I need to move it 2 places. Multiply both sides by 100. We'll move a decimal point 2 places. So I have 2, 1, 5. And what's behind that 5 are just repeating 5s. All right, so I'll put it back in repeating bar form. So put a bar over the 5 that's behind the decimal point. Now, if we look at the two equations, this new equation and the original equation, I didn't achieve that goal of having only the repeating blocks behind the decimal point. In this new equation, in the first equation, there's this 1 that's also behind the decimal point. So what I'll do is I'll multiply both sides of this new equation by a power of 10 to move that decimal point so the only thing behind the decimal point is the repeating 5. So to do that, I need to multiply by 10. 10 moves the decimal point 1 place, 100 moves it 2 places, 1,000 moves it 3 places. So what I'm left with is 21.5 with a bar over it. Now if we look at the two equations, the only thing behind the decimal point is the repeating 5. So now I can subtract. So 100x minus 10x and 21.5 with the bar over it. See those repeating 5s drop right out. So 100x minus 10x, that's 90x, equals 194. Okay, and then I'll solve for x, dividing both sides by 90, and I get x equals, I'm going to reduce that, 97 over 45.